So first of all, thank you everyone. Thanks for being here, uh, for attending my session. And I'd like to say thank you to the organization of Scala UA as well, especially given this crazy situation that we are all living in. They managed to accommodate everything, make it easier for all the speakers in order to have some knowledge sharing related to Scala. What's great. So thank you for everything. Well, I'm here to talk to you guys about manipulating abstract syntax trees in order to generate safe SQL queries with Quill. What some knowledge I acquired since I joined that project. And then I try to shape it and share a bit of that knowledge through this talk. So first, a bit of myself. Who am I? I am Juliano. Hi. And I am a Brazilian from São Paulo. I'm actually living in London, UK. It's been about 4 years. I am a software engineer. I am a searcher of perfect modularization, and I am a lover of functional languages. I decided to put these titles in order more or less like Game of Thrones style. I'm a big fan of Game of Thrones, but that's not the next line. I have experience with some of the cool modern functional languages, and I have experience, probably a lot more experience with the vintage ones as well. Still cool, not as functional. And besides, this is my Twitter, and that's my website, my blog, where I write mostly about Scala and Clojure. No, sorry, Scala and Rust at the moment, developing some nice new things in Rust. And I see myself as an open source developer. I enjoy that a lot. Something that's not here, though, is the fact that I'm a big fan of Forrest Gump as well, which means that I will start this talk with a quick story, actually. And this story is about myself. I'm talking about me, right? And I went to university some years ago, and I studied computer science, what was very interesting. And I still have the feeling, I still remember what the feeling of going to university for the first time and having all those possibilities in that course. So I started dealing with like all these different operation systems, and then suddenly we have like all the sort of different devices that we can somehow build things on top of it, and applications, and make they dance, and so many nice things. So many languages, could learn so many different languages to build those applications running all those devices and all of those operation systems, even to the level where we could build our own games. It's something quite remarkable. Oops. Okay, never mind. Quite remarkable in that sense. I was amazed. I still remember that. And we start studying, and you have like super, super nice topics at university. And you have ones that don't make you that happy, right? I mean, I still remember going to the class about compilers. And even though I enjoyed a lot of other topics, I cannot lie about it. I was super bored. It wasn't my favorite topic. It was the sort of thing that, you studied and you think, why am I studying that? What I'm doing here? That's a waste of time. I mean, I'll never use it, right? I'll never build my own compiler or my own language. Who does that? So yeah, that was the context, but time passed, right? And as I've already said, I became a software engineer. I grew a beard as well. That's very important. I developed a better understanding, and I could make more reason when I was working with strong types, and especially thinking about functional programming. Scala became my favorite language among the others that I worked with. That was the one that I could represent, abstract the real world in the best way, at least from my perspective. Interesting enough, I always enjoyed complex problems. We have our everyday jobs where we build regular apps, let's say. You guys know what I'm talking about, RESTful APIs, this sort of stuff. But extremely complex ones always caught my attention. And last but not least, I always enjoy working with open source, somehow taking part in it, participating, contributing, finding bugs, helping in issues. I always enjoy this community and the way it works. So not longer after that, I joined Quill. I started contributing to Quill. And who here can, between you guys, let's see, can you digitally raise your hands if you know already Quill? You can maybe use the chat and send that emoji with like raising hands, possibly, difficult, I don't know. Yes, more or less, it counts, it counts. So, well, for the ones that don't know Quill, Quill is a link for Scala that allows you to generate safe SQL queries given your crazy classes and a code that's writing collection-like code in Scala. You can generate your SQL in compile time, except for this quote here. Oops, where is it? Here. Oh, this quote right here is the exception. Maybe the query as well, but everything else relying on just case classes will build the code for you, the SQL code for you, right? So if you don't know it, check it out. Makes your life super easy when it comes to SQL. And I had to learn about Quill, right? I started contributing, and eventually I wanted to know more and more about the complexity of it. And this is a general overview of how Quill works. So like I said, we have this quotation mechanism here, right? And this part here in red, it's related to the compiler. So we have a macro engine that will somehow transform that code in something else. It will actually extract that to the Quill AST, obviously, giving the name of the talk, the main topic of this one. This AST will at some point become SQL, and then we'll generate like a log for you, right? So let's think about it looking at this part right here. At some point, when I got involved in this project and I had to study more and more, I had to start looking closer, right? And then looking closer. And suddenly I realized that a good amount of that topic is strongly related to compilers and what I didn't exactly enjoy at university. So I would have to study and relearn the topic that I kind of neglected at the time. Happens to all of us. Huh? Okay, so first of all, what is an AST? An AST, an abstract syntax tree, they are data structures used to compilers to represent the structure of our code. So it's pretty much, as it says here, it's an intermediate representation of that program, keeping some of that information and later on generating an outcome from the information that's provided, right? So if you look to the right-hand side, I hope it's your right-hand side as well here, you see this graph that's quite simple, showing some of the instructions we use in well-structured programs like while, return, assign, comparisons, variables, and this sort of stuff, right? Every language is has this sort of abstraction behind the scenes, even though most of the time you don't even have to think about it, right? So thinking about it in a more concise way, we are talking about Quill, right? As the name of this talk suggests, we are talking about Quill's AST. So remember, I'm not discussing how the macro engine works. I could actually pick back on what the Yuri's previous talk. That was very interesting because he was discussing Dotty and how that can be beneficial. But we are not talking about that, right? We are talking about the moment when you already have an AST and from that moment on. So this is an overview of Quill's AST, right? So we have this abstraction AST, obviously, and we have some other abstractions, though I'm going to walk through every single one of them quickly. But we have those as the main abstractions in Quill AST, being query, operation, action, so on and so forth. So if you look at every single one of them, they represent almost every single action you can execute. So let's have a look. The first one is a query, and a query represents database / collection actions. I name it that, I call that in that sense, mostly because, then again, working with Quill, we are writing collection like Scala code, right? So I don't write, I don't know, cars.where. I want to write cars.filter. Reason why we have this filter one here. And if I'm picking one specific field from car, let's say number of doors, I wouldn't say select that like SQL style. I would say map and transform, pick just that field that's relevant for my query. So this piece of the AST represents all these operations, collection / database ones, right? The next one is an operation. An operation basically happens between operands and operators. So obviously we have here an operand in green and the operators. Those are the components of what we consider inside Quill an operation. The next one is an action. And I see an action pretty much as a statement, more or less, except because when I look at the for each here, for each is a handy action as well, but not a direct action that we run direct statement, not exactly. But then again, it's an abstraction. Everything else is clearly based on SQL statements like delete, returning, update, so on and so forth. The next one is ordering, and ordering defines the order, obviously. We have what is considered a value giving different contexts inside Quill, being constants, no values, tuples, case classes. It's smaller than expected. What is considered a value? We have lift value. Lift represents lifted values and structures coming from outside the quotation scope. That means that those are values that are not defined in compile time. They are runtime values. They are values that our user is sending to us, and suddenly they become part of our queries. This one, it's likely that's a bit outdated, given that we have already some work going on in order to have Dotty, Quill running with Dotty. And there are some extractions going on from regarding the AST, but that's the general representation of a lift component of the AST. We have iterable operations that are very specific, just those three, for map contains, this contains, that contains. And then we have the option operation that knows absolutely everything that has to know about options. Last but not least, we have some other elements, the ones that are not exactly connected to those elements of the AST, which I call the main ones. Those are more like the lone wolves. They are there for some specific uses. They are part of the ACT as well. However, they are not connected to anything else, right? So that's a complete-ish Quill AST overview, right? That just gives you a general idea of what that quote, the quote code can become inside of Quill, right? So quickly reminder that we have the quote code. It goes through the macro engine. The macro engine will generate some sort of tree based on these components you can see on screen right now. But that's enough, right? Like, show me the code. Let's see how it actually works. So in simple terms, we have this, let's say this case class person here that just has an ID and a string, name, age, etc., etc. And then we have the address that has an SK that's an option of an if. It's a very simplified version of objects, of components of our system, right? So when we build a quote that simple, a quote of query person, and then if I try to, using pprint here, very useful, I could just check it out what the AST generated here. So I would just have like an entity, person, and list, and empty list. Let's say that I build a query that's slightly more, has a little more in it. So let's say that we just have a filter by age that's like greater than 25. In that case, our AST is already way bigger than it was initially. So we'll have in this moment a filter around that entity we had before, right? We have an identifier here, and as you can see here, we don't have any sort of identification, which means that Quill will generate that for you. And then we have a binary operation that, like I said before, we compare like a property, and then you have an operator here and another property, right? If we try to map after filtering, our AST will get a bit bigger, and that whole filter we have in the first one here is inside the map now. The map with another identification, another ident here that doesn't exist again, we'll generate it. And then we have the property that we actually want from that quote. This one is just a bit more complex again. We have a left join now, where I'm just saying that I'm querying a person, I'm querying addresses. On the case where an address has an SK, right? The SK exists, and it's the same as the ID of our person. And in that case, we will just map here the name and then the SK. And when I print this AST, I already have a lot more in that AST. So as you can see, we have the map, we have joins, and we have left joins. So giving that code, the macro engine will somehow follow a series of instructions that define how that AST will be assembled, giving that code, right? As long as your code compiles, you have an AST. That's valid or not? No, the AST is valid. You can do some funny stuff that will break if you try. Never mind, that's not that important. But that code, that quote code that we have, that will generate that AST. However, let's use SQL as examples here. And at this point, probably you cannot see how that will become SQL. And I didn't show you an example of this running code, because some other important topics have to be clarified before we do that. So before I tell you how Quill parses this AST into SQL code, we have to talk about tokens and tokenizers. So a token is a sequence of characters that can be treated as a unit in the grammar of the programming languages. Translating that to simple terms, I would say that a token is pretty much a sequence of characters which represent a unit of the source program, right? So let's say that identifiers or operators, they are tokens. Keywords are tokens, right? You can have a look at this link here that explains it in a fairly simple, understandable way. So let's have a look at this trait here in Scala, part of Quill. We have this in the statements file. We have a trait called token, And funny enough, I had to update it yesterday because I was having a look at the code, and because of the already mentioned extraction that's going on, we have now this tag token here. But we have, I think, 6 implementations of token. So we have token, tag token, we have string, scalar, quotation, this one is new. We have scalar lift tokens, statements, set, contains tokens, right? And why I'm showing that, at the end of the day, our goal here is to generate some SQL, right? So we have, okay, here's the thing. Quill still relies on Scala. Quill intention is to not impact your everyday job that much when you are writing Quill's code, meaning that everything should be exactly as is, except for small details like quotation and query. So we still rely on the whole Scala compiler / ASTs. However, we have to introduce some values for some specific values to the AST. We are adding a few more because that's what we need to later on interpret your code. So everything, that's why you can write usual Scala code and flat maps and everything else. However, for some specific case, let's say when you have a runtime value, you have to leave that value, or when you are quoting that with Quill's quote mechanism, that will generate what's a quoted value right here, and we need to know that. But other than that, that's pretty much the tokens we add in the first moment to the AST, right? So yeah, so that's the reason why you're talking about tokens. Why is that important? Because that's the way that we can work out results of that AST. As you can see here, every single AST has a token. So being the CO trait AST on the top of the hierarchy, by definition, every single one of them, they have a token that will be used to generate a different outcome later on. And how do we do that? Besides having the idea of a token, we have the idea of a tokenizer. A tokenizer is the guy that manipulates the tokens. They can be called lexicals as well, if I'm not wrong, lexicals. They are at the same time, while we're studying, I didn't get to a consensus if they are exactly not the same or not, but they are the guys responsible to manipulate tokens inside Quill's domain, at least. So that said, let's have a look at one of these simple tokenizers, one of the simplest implementations, actually. So we have this straight tokenizer that there's a method token that receives a value t and returns a token, right? And as you can see here, we have these tokenizers for lists, for strings, and we have many, many, many more other implementations given the vast Quill AST. We have implementations for pretty much every single one of those elements, right? Because we have to interpret some of them. So instead of just explaining the theory behind tokenizers, let me propose the following. Let's tokenize it ourselves, right? So using one of the examples, one part of the code that's already actually in Quill, we have in this SQL query file, we have this case class called flattened SQL query that extends the SQL query. And as you can see, it has all the elements of a basic select, right? A select statement, as you can see here, from, where, group by, order by, limit, etc., etc. For some reasons, select is the last one here, not the last one, but it's at the end here, and distinct is the last one. I wonder if during development, they forgot to add distinct in the first moment. That's why it's the last element in the list here. Let's stick to the SQL statements, the SQL terms, the ones you already know. Let's not consider specifics of the case class that we are operating upon. So let's say that's a case class person. Let's ignore that for now, all right? Let's just translate the tokens related to those specific SQL contexts. So for instance, We start with, in this flattened SQL query tokenizer helper, we will have at this point this distinct tokenizer here. Let's assume that the product we are working on, it always is fulfilled with everything, right? It has all the fields in it, meaning that when we match it, it will have some sort of value. And then we'll generate the first initial statement here, right? The distinct tokenizer, we have the value, so that's the beginning of our output, all right? So we have that, and you have something else to keep going. The next one would be with from. And let's just not focus on the proper pattern matching. Let's say just that we have some value in it, meaning that we will generate another statement here, right? We are accumulating those states, as you can see, with distinct previous one, and it keeps going. The next one, obviously, would be where, and we have a where condition, right? So when you generate that where with our where token, we have that. The next one with group by, we have group by token. Nice, that's what we have at that point as well. Then we have order by. As you can see, order by has a specific method here to evaluate the criteria. And then we have our select statement with an order by. We will have our offset as well. Let's say that we get this one here with just limit without offset, for instance. What will generate this SQL statement at this point without evaluating criteria, fields, everything else. Last but not least, we have our select, a very simple one at this point, meaning that we have a select distinct from where group by, order by, limit, so on and so forth. That's what the tokenizer does. That's a very simplified explanation for what the tokenizer does, because looking at SQL normalize and the method, this vol normalize, it composes many calls for many different functions that will run all sort of roles that will actually generate that valid SQL, correct SQL for you at some point, right? And how do we do that? That's actually, I suppose it's quite obvious at this point, that to evaluate that, everything happens through implicit resolution, right? You've seen the tokens and the tokenizers declared as implicit defs, implicit classes. So that's the way we can evaluate that. So if you go back to those queries we built at the beginning, just a quick reminder, we have a crazy class person with an address, right? Then having Quill here and a context, we can just generate, again, this is the AST. And I suppose at this point, you can see how this AST became this select here, right? And the next one would be that one. I think it makes it even easier to understand, right? Obviously, given that tree structure, we evaluate everything from the inside to the outside, at least looking at that pre-printed AST. That's how we define that. So we finish this one hand at first, and then the filter outside first. Obviously, as a tree, it's the other way around. Anyways, being a tree, it has to be resolved recursively. Our code tree, our code tree with the filter and map, same way we generate this query here, and that final query we had with the join would generate that's the AST, would generate this SQL here, applying the left join according to the definitions by our consumer. Okay. There's a topic that's important to be discussed at this point. That in the first moment, it seems a bit on the fly, the fact that I'll be talking about it, but I promise that will make sense. I have to quickly tell you about beta reductions. So let's have a look at this code right here, right? We have, using the same case classes, we have a quote for a query person, mapping the ID and filtering by one, when it's greater than 1. And I do almost the same when I'm working with address, with the difference that address doesn't have a long int ID. It has an option of a long whatever ID. So after mapping it here, I have to filter that using exist. As long as that ID exists in the option, I can do so, right? That's in the Scala level. And then let me print out both of those ASTs. And doing so, I'll have the filter for the first one, right? The one without the option, and I have a different one with the option. Even though they are different, I still have the same binary operation on top of both, right? And the interesting thing here is the fact that when I execute this, when I run those queries through a context, that's actually the result I'll get. The result is exactly the same, even though, as mentioned before, every single piece of the AST actually has a representation. So do we have exactly the same representation when working with options and when not working with options? That wouldn't be that smart. So that's where we need the concept of a beta reduction. And a beta reduction is the process of calculating a result from the application of a function to an expression. That I really like this description. It was like the easiest I could find. At the end of the day, what it means is it's a substitution, right? So let's have a look at some code that probably make it easier. So going to flat option operation, as you can see here, at some point when we are receiving that AST, we are pattern matching that and verifying that if the option exists. Let's look at this guy. If contain, ignore this. If, let's say that's the case, we will have a reduction here, and we have an apply of beta reduction, where we will be using the body of the AST here, and then we are creating an entry for a map through the alias to the initial AST. In our case, we are talking about here, the binary operation is the body, the last element, right? And when we look at beta reduction, we will find another pattern match for, let's say here, option exists. That what it does, like I mentioned before, it will apply, it will call apply that to be solved via resolution later on. We'll apply that to the value of that option, and then just create a new one, applying that value, and then beta reducing the replacements. Replacements are a map with element that should be replaced. Removing the second one. So what it means is we are skipping that step because there's no point into evaluating an option operation. Let's say option exists operation. And as you can see here, some of our operations, there's no point in actually evaluating that because the principle is the same. The option is an abstraction in the Scala world, but it doesn't make sense in SQL, meaning that you can just substitute and kind of skip some of that. The option doesn't have, and the option won't generate an output at the end of the day. It's there for our use as Scala developers, but for Quill, we skip. We'll substitute the option operations, right? That's the simplified version of beta reduction. And the next, I needed to explain to you why I had to talk about beta reduction because that is vital for the next and final and my favorite topic, that's optimizations. Okay, so let's look at this example here. We have this case for case chaos person. We have this quote that's actually a function that takes a string, and let's say a very simplified quote, right? Let's say that when this value, we are selecting people to have drinks, they have to have an age that's greater or equal to 21. I hope that in the everywhere, people, at least in the Ukraine as well, is 21, the minimum wage, right? Back home is actually 18. Anyways, so what I expect from that is, okay, I have this quote here that's actually a function, right? That takes a string and produces a query for a person. So when I do so, if I have a look at the AST, what I have here is a function of a list, and then I have the if here, as you can see, with the filter, and then the entity here, right? Interesting enough, I can have the AST of the applied function to a value. So let's say that we have here, we are calling the quote with drinks, um, with the passing the value to the string, and then printing the ST. And at this point, what I actually have is an if of a binary operation, the then query and the else query. But wait a minute. At this point, I already have the values I need to evaluate that condition. And because of that, I already know that what I'll execute is actually the then condition, the first clause. What if we had a way to skip everything else, given that we know the result of that evaluation, and just drop it? And instead of going through both conditions and trying to translate them, we just ignore that. And at this point, I think we already have everything we need to do so, right? So we had pull request open at the moment that intends to provide such feature, that's the beta reduction for trivial conditions. It's kind of experimental. You have to actively introduce that here. It's a work in progress as well. But let's have a quick look at that. It's a very interesting topic in the sense of we have a class, a Scala file trivially checkable. And that's a very simplified version of it. There's a lot more. But at the end of the day, when we are applying part of our AST, we could check that if we can parse that and verify that they are trivially checkable, very simple conditions, then again, it's a work in progress. And we verified that the first one is actually equals to the second one. I know that's already true. And if it's not, I know that's already false. Knowing that, I can better reduce my AST. Again, the same way we do with options. But at this point, if I know that that condition is trivially true, like we have here, then I know that I just need the then clause, and I don't care about the else clause anymore. So I can just better reduce it. And here we have this call reduce trivials, applying just the then clause. Or otherwise, if it's checkable and I know that's false, I can just apply the else clause. Meaning that when I go back to my code right here, I can just say that running my quote with drinks, I know already that I just need the filter, and then it will better reduce it and just deliver the filter here. And when you run it, obviously you have the correct SQL. And otherwise, if I provide the function with whatever else, I'll have a result that use the else condition. So at this point, we are just ignoring the code that's unreachable. What's wonderful, I mean, we don't actually even evaluate that. It's my favorite topic, and I found it mind-blowing when suddenly we start to realize that we could have this power over the tool, providing an even more performatic code that's not even being compiled, it's just being skipped. So the interesting topic is, like, can we optimize listed values? Possibly. As you saw in the previous talk, Dottie will actually give us the information. Okay, I won't just affirm that, I hope, because I haven't studied that enough. But Dottie will provide us the information in runtime that we need to do so. Today, what we can do, if I try to lift a value, I have this information here, but we kind of lose this information at some point if you are trying to do so. So it doesn't work. The truth is that won't work at this moment in time. Hopefully, with Dottie, we'll be able to make it even stronger, and then we'll have more information about lifted values. meaning that you'll be able to reduce those queries that have the if cases and whatnot. So the conclusion is that Quill is what I like to call a domain-specific compiler, a mini compiler. And by that, I mean that Quill, using the concepts, the same way we do that with domain-specific languages, that you make use of a bigger environment and you define a smaller a subset of that environment to represent something that's convenient for us. That's what we do with Quill, using the compiler and using the knowledge and the resources the compiler provides us. We can, through building our own AST, we can define and manipulate our own domain, right? So that gives us, then again, using the compiler, we have the type checking, so we have correctness. If your code compiles it to generate SQL, correct SQL, that's the main idea. We have the normalization that we define transforming and building outputs, which means that even though I'm using SQL as an example, but we actually generate specific SQL for MySQL, Postgres, SQL Server, and Oracle, and other different, slightly different databases, and sometimes very different ones. We can generate using the same quotation, running that with a different context. We can actually generate safer SQL for Spark or Cassandra or OrientDB, and having different implementations of the runner, we can produce different outputs. And last but not least, if we have this understanding of the compiler, this knowledge allows us to improve how our code works, going for just what should actually be used, just dropping what's not being used at that very moment. The compiler allows us to do that in a safe way. And if you want to contribute, if you want to learn about a lot more about compilers, I suggest you to have a look at Quill. Just reach out, send us a message. We have like many issues to be solved. We have a lot of interesting stuff coming on, migrating to Dotty, extracting the code that will allow us to keep our quotations. The macro engine will change. However, Quill quotations probably will stay. How do we do that without breaking everything? I think it's a really interesting challenge. It's the sort of thing that we don't do in our everyday jobs. So if you'd like to learn more about how to explore the compiler capabilities, join us. This is the project we're looking for. And that's what I had to present. Questions? I hope we have time for questions. If we do, otherwise, thank you very much.
Thank you, Juliano.
Thank
Good
you.
job.
Great job.
Any questions?
Bye.
I proposed.
In the case where we don't have time for questions, please just reach out, send me a message on Twitter. You can find all my contacts on my blog. The link for my slide deck will be there as well. Just send me a message if you want to contribute, want to know more. Just reach out. It's a very nice tool. I enjoy a lot.
Juliano, have you tried LinkU and how you feel it from C# world?
Yeah, I worked with Link a long time ago, but okay, Quill is actually based on a paper from, you can see the link in the site, and actually the initial idea is implemented in F#.
Mm-hmm. Yeah.
Because as far as I know, F# has a relatively easier mechanism to provide quotation, right? Quill had to implement it from scratch. And the same way that Clojure had already the idea of quote by itself. I mean, it's not a fair comparison, but going back to your question, I used Link, but it's been quite some time since I worked with F#. And after getting involved with Scala, I didn't think about, let's see how this implementation works. But to be entirely honest, I kind of doubt that would be very useful for us, mostly because everything that F# does is verified, and because of erasure, probably would be a matter of looking at that, saying that would be great to have in the JVM, and then to being like, yeah, I don't, so let's solve it ourselves.
Okay.
But But I haven't tried to compare that, to be entirely honest, other than the examples I saw in the F# world.
Okay, you know this is fine. It's okay. Thank you very much. Great talk. Great work.
Welcome. Thank you very much.
What is your daily stack, daily set of libraries, that stack which you work usually?
At the present moment, I'm not working with Scala on my everyday job anymore. I'm back to working with a standard Java usual stack with Spring Boot and whatnot that comes with that. On the interesting side, I would say nowadays I work for TransferWise, so we have like many services. We rely on Kafka, work on Kubernetes. We have some other initiatives with services in a few services in Node, some services in some development in Kotlin, especially when it comes to obviously when it comes to the Android development, and a few small services in Python, Ruby, and Kotlin. But nowadays I mostly work with the Java stack again.
And it's more server side.
Sorry?
It's more server side.
More server side. I work in a team that's a lot more on support of integrations at this moment. So yeah, mostly on the server side.
Quill is based on SQL. It is no, Quill is a wrapper over SQL, yes, but how about NoSQL?
Yeah. So actually, Quill is not exactly a wrapper, right? We translate the Scala code, meaning that we can have other databases as well. Quill can support more databases. Quill supports Cassandra, for instance. And let's say that we'd like to have a Quill MongoDB module. It's possible. It would be a matter of implementing all the specific details of that language, right? What's harder in the sense of, let's say, Quill Spark, for instance, Spark is still SQL-like-ish, right? There are many similarities, what makes it easy to reuse what's already there. But let's say MongoDB would be a matter of implementing the whole module from scratch, at least when it comes to that specific idiom. So, and if I'm not wrong, there's an issue open. It's one of the oldest issues actually to implement Quill MongoDB. However, I don't see many people asking us to do so. Maybe not that many people using Scala with MongoDB, possibly, but it's a possibility, of course.
So maybe Julian, maybe you would like to add something that is pretty important or interesting from your point of view. Maybe you had some lack of time to deliver some piece of information.
Something that I think maybe if I relate to the question regarding Scala 3.e, something that caught my attention a lot was when Zio started to become a thing, right? Okay, this relates to my my current job, right? Because most of the services are Java and everything. And then I started to think, how can I sell the idea of Scala? How could I use that in a proper way that I can replace one of the services, showing some values, right? Like showing how much better some things could do. And to be honest, I found it very difficult. I started building a simple service with cats, kind of a new version of that service. That's just an API. And I started to realize that the F underscore pattern, how obscure that can look like to someone that doesn't know Scala. At some point, when I was having to say F underscore, and I have to use sync, I have to use some particularities of the cat stack, I realized I was like, I'll never convince anyone that this is simpler. It's always taking in consideration that I'm trying to explain it to someone that doesn't understand it, right? It's not about all the benefits it can bring, because if that person doesn't know it, there's no benefits whatsoever, right? As long as they don't understand that, I would have to teach every single person. But if in the first moment I already show something that looks very difficult, I cannot make a case. So I decided to try to do the same with Zio. And I think Zio has he was designed considering that it should be relatively easy for the end user to use that, right? Someone mentioned in one of the, I think someone mentioned in one of the talks that people assume that we, as functional programmers, we assume that everyone understands everything we are talking about, right? That monads and function composition are things that are trivial when they are not, actually. For a lot of people out there, they are not. So I think Zio is something that can take that position. That's not too magical, and there are no use of very complex patterns, right? You can tell that you are building layers. You can tell where you are using them. At least I think that it could arguably be more complex. However, I think it's at least a tool in which I can build something and make a case saying, yes, maybe it's a bit more complex on this side, but if something fails, you see during compile time here, and the message telling you, oh yeah, it's lacking the environment here, so we know exactly what our services are, the dependencies are. It's breaking and telling you exactly where it's failing. So I think it's possibly the tool that where we can build something and then again make a case. What I mean by that is that possibly we should, when we are building our tools, our new libraries, we are trying to enhance this awesome ecosystem. We should think about how we convince people that are not part of this ecosystem why they should adopt those tools. So I think that's something that Quill kind of does, because it's not that difficult to adopt Quill, right? However, Quill is still strongly dependent on the Scala ecosystem, meaning that every single one of us, the ones maintaining libraries, we should always think, okay, how can I make it as simple as possible that I can actually sell it to people from other communities, from the ones that at this point they don't understand it, but let's make sure that the path to start using that tool is relatively simple. It's something that they can read, they can look at that and that's kind of difficult, but I can understand what's going on. So we should make sure that we don't make anything way too magical. Let's make things relatively easier to understand so more people will buy it. I hope that's the way we can make sure that this community keeps growing. That's what I have in mind.
Among the questions in your Slack channel, so I see some question that I would like to ask you to explain in more details, please. So the question was how Quill interprets AST. So could you provide more details, please, on that?
More details on how it interprets the AST?
Yes.
Quill's AST.
Okay.
Because if I ignore the way that the macro engine works, right? The macro engine provides me the AST. So what happens is every single one of those nodes talked about during my talk, they are pieces of that AST, and every single one of them will have a token. And a token is at some point a representation. That token will be translated to something different. You generate a different output. I could say that it always generates SQL, but that's not true, right? Quill generates more than just SQL. Like I mentioned before, it could be generating a query for MongoDB. In that case, wouldn't be SQL. And for Cassandra, it's not SQL as well. So that token later on will become, according to one specific context, let's say that's a SQL context, let's say it's a Spark context, we'll generate a specific output for that AST, meaning that at some point, if we adopt, if you use SQL context as an example, that will become a piece of the SQL query. So if we use, for instance, we create a quotation of a case class A, and we filter by B being greater than 1, right? We'll have that specific AST where we start to translate in parts where we'll have an entity reference to our case class, for instance, and we have the filter that at some point will become that where part of your SQL. So we build an AST, and then we evaluate that we will have to go through the whole AST or the whole tree, picking the pieces that are relevant for us. And at some times, like I mentioned right before the optimization part, sometimes we just bypass some of them. What happens a lot with, let's say, options, for instance. Options are very interesting for us as developers, but when we are dealing with SQL, the concept doesn't exist. So that has to be translated, and many times the idea is exactly the same as if you're using a concrete specific type. So when I deal with an option of string or a string, the final result is the same. So I can skip, I can reduce one of those steps. I hope that answers the question.
Cool, thank you so much.
No problem.
One more question, may I ask?
Sure, yes, please.
Yeah, so the question is about whether Quill is ready for using in big project. I mean, hundreds of models, dozens of queries. And I ask him because compilation times, and is there any approaches to improve this? Like, for example, in Scala JS, there is fast optimization and full optimization.
Well, it's production ready. It's being used in production for quite some time. But Quill is not an ORM, right? It helps you to generate your SQL queries, and from that point on, after the compilation, when you executed them, it's very performatic. It runs quickly, mostly because the way we run that query using the context is the way that you tell us to do so. So let's say you're using the JDBC module, it's very, very fast because at that point the query is already in place, everything. Let's say a time compiled query, everything is already in place. So I'm just executing the prepared statement straight away, which makes it very fast. We don't have the idea of intermediate steps like, I don't know, second level cache, first, second level cache, none of these things. It's not an ORM exactly. It's not an ORM at all, actually. So we can think about Quill as the two modules, the one that generates a query, the one that executes that. The first one mostly happens in compile time. And maybe because it's heavy used with macros, if you have way too many queries, it starts to make your compilation time a bit slower. It can happen. However, during execution time, it's a lot faster because there's no work to be done anymore. The queries were already generated and they are part of your code, safe and sound.
Okay, thank you.
You're welcome. I cannot just affirm that. I'm not entirely sure. But if I'm not wrong, Flavio, the guy that created Quill, he's an engineer working for Twitter. I can guess that Quill is used on Twitter, but I'm not affirming that. I'm not entirely sure, but it's very likely.
Maybe you have already answered that, but is it possible to re-implement your software with Scala 3 macro system, or have you already thought about that or not? It's about Doty's macros.
Yeah.
Are they suited to your developments, or you have to rewrite everything?
So at this point, there's already some work to be done in order to start using Scala 3. Some of the core modules, we can still use them. So we have the, I think they are called portable now. So we used to have Quill Core and Quill SQL, for instance. They are quite important inside the project. And Alex managed to extract parts of those two. What they became Quill Core Portable, something like that. The other one, Quill SQL Portable. And those are the parts that we can reuse. The macro engine, a good part of that, it's not that we actually have to rewrite everything. It's more like we have to be able to delete a lot of that code, because the macro system is very, very, very complex, right? And with inline, a lot more information that we would have to do crazy things to keep it, that we use later on. It's already provided, and because the whole new macro type system, it provides a lot more. The type system is a lot stronger. We will be able to delete a good part of that. At the same time, that way we'll make sure that we're still the modules running on the other Scala's versions are still going on. We'll have to keep all of that, right? So we have the portable one. That's pretty much the basic Quill quote that will stay. It's convenient for us if it stays. And then for Scala 2, we'll keep the modules as they are today. For Scala 3, we'll have the new ones using the new macro system that will be way easier for us to reason about. And actually, not just that, provide more features when it comes, for instance, to runtime variables, right? Nowadays, we don't have a way to use them, but with Dotty, we'll be able to have more information and hopefully make more optimizations, for instance, when we are dealing with lifted variables, runtime variables. So it's a very interesting time to join the project if anyone is interested. Because at this point will be a lot of work related to moving those pieces related to Dotty. It's a very interesting one, very challenging, but at least it's like I said during my talk, I really enjoy this sort of work that we don't do on our everyday jobs. So it will be a very, very interesting challenge. But at this point, Alex is the tech lead of this project. I suppose he's the one that knows the best. He spent quite some time studying how our macro engine will be migrated to Dotty. And we had a call maybe 2 weeks ago where he explained some of his learnings, but I will still have to put a lot of effort in it to make sure that I'll be able to work out that area as well. However, it cannot be more complex than what we already have when it comes to macros. What's great. But it'll be an interesting thing to do, moving those pieces, especially when you're thinking about macros, right? It's like time works in a different way. What makes, at least for me, I found it super complex to make reason of when some steps happen. So to detach them, to move them in different directions and make different components will be quite a challenge, but a very interesting one.
Okay, thanks.
Thank you. Thanks, everyone. Have a great day.